In this part of the assignment on cost surfaces, we will continue work in the same map set. In my case, it's assignment 3. You may call it something different. And we will use the same working directory that we set up before. And we have downloaded into this directory all the rules and colors text files. We will now use the cumulative cost surface concept to map how far could a person walk from a given point with spatially variability walkability environment. So let's first remove all the layers that we don't need anymore. And we can also remove this legend. And let's set the computational region. It's probably the same as the previous one, but just to make sure. And now let's look at the categories in the land class map layer that we will be using to generate a friction map. So you can see that we have categories from developed to water and sediment and forest assigned different numbers. Now we will use the recode friction rules text file that we have downloaded, and we will assign these categories different friction coefficient. So you can see that the developed areas, agriculture area through the category 3, which is herbacées, which is usually lawns and grass, have very low friction coefficient, while the water, that's category 6, has very, very high friction coefficient. And in this way, we essentially are able to represent that it's much easier to walk through developed areas, and we will essentially prevent the person to walk across water. So let's use these recoding rules to recode the land class map layer. And we will get a friction map. And you can see that in this friction map, we have only two colors show up. And that's because we have several smaller values and one very large friction value. So that means that if we want to see this, we will need to change the color table. But before we do that, we will also include a very low friction value to the streets layer, which are missed in the 30-meter resolution land cover map. So let's do that part. And we will use map algebra to replace the grid cells in the friction map that we have so far with the low friction along the streets. And we will use the street speed raster file that we have generated already for a different task. And now we will use a special custom color table to represent these updated friction rules. So you can see that our friction map now is very nicely represented. We can add a legend that shows the friction values. Let's put it here. And we can save this friction map for our report. So here the gray color is very small values and the blue color is very high values. Now, the elevation, impact of elevation, that means the steep slopes or the flat areas, are incorporated in the cumulative cost module, which is called r.walk. So you can see we have elevation map as an input and we have friction map as an input, and we will get a cumulative cost map as output. And we will limit the distance where we will compute the cumulative cost map to a fixed value given by the cost of 10,000. And now we can also highlight the individual intervals of how far the person can go by generating isolines, isochrones. So those are isolines of the same time. And then to create the final map, we will also import the point from which we have generated this cumulative cost map. And that's essentially the point with these start coordinates. So now if we want to put it on the map, we need to import it. And now let's just erase the maps that we have so far and create a new map that shows the results that we got. So we will change the color map for the cumulative cost map to make the map more readable. So we have used the histogram equalized color table. Now we will add the lakes. We have the walk cost there already. We will add the streets for context. We can add the isochrones. I will add them in orange color. And we will highlight the isochrone 6000. And then you can think about what units these are, what this 6000 means. How far would the person get from that given location after the time represented by the number of 6000? And we will highlight where that person was located. So this is the point from which we have computed the cumulative cost surface. And you can see wherever we have the streets, that's where the person can get the farthest. Wherever we have the lakes, there is like this big barrier where the person can't really cross those lakes. And that's because we have put very low friction value over the streets, and streets are also usually flat, lower slopes than the surrounding landscape, and the lakes have very high friction value. So let's also put there the raster legend for this final map. Put it here. And we can remove this one. And you can customize the legend in a different way, but let's just keep it this way. Oops. Okay. And we have, we also have the vector legend included that shows what these isolines mean and what the point marker means. And we can now save this map. And I will just save it like this. And it should be saved into your current working directory. So now don't forget to include this map into your report and answer the question, how did we ensure that the person does not walk over the lakes? So how do we incorporate that information into our model? And then the rest of the assignment is optional, and it includes the finding developed areas that are close to lakes. So that's a buffer task. So if you want to practice more map algebra, more buffers, you can, and reporting areas, you can do this additional assignment. And then the last optional task is the shortest distance map and cost surface to highways from a surrounding area.